Hello everyone, and thank you very much for joining this live event. This is already lesson number 8 from the Spring Security stream, and we'll discuss about the security context. Well, basically we planned to discuss about the security context in the previous lesson, but I was unaware of how much work should I still do on the application I started in lesson number 6. And that's why we didn't actually do anything on the security context in the previous lesson. We did also work on the application with our multiple implementations of authentication providers. That's why I have also renamed the lessons. So you see lesson number 7 is now the part 2 of the multiple authentication providers, and I have named this lesson the security context because this is what we'll discuss today. If you are watching the event live, don't forget that you have a live chat there, so you can ask me questions directly in the live chat. If you are watching the event recorded, you can still leave me messages or questions in the comment section. And don't forget that you can also find me on LinkedIn or Twitter, and you can ask me questions there as well. So let's see what's with this security context, and let's continue with our application that we've started in lesson number 6, and we have finished it in the previous lesson. Well, actually at the end of the previous lesson, if you'll watch the recording, you'll see that my application was basically failing to start. And it wasn't a problem with Spring Security, it was actually, shame on me, a problem more related to Spring fundamentals. I have somehow created a cyclic dependency, and because of that the application is not starting. So to solve that problem, I have simply moved the definition of the bins from the components of the filters. Instead of defining my filters directly as components here, so they are picked up when the packages are scanned, I have actually defined them directly where I need them. So this is directly in the configuration class, and then I simply call them when I need to do my configuration. So with this change, the application is no longer failing because I have eliminated the cyclic dependency. This is not the only way to solve the problem. Somebody suggested making it lazy loading, and that could work as well. I'm not here to discuss basically about how it's best to create your bins and injections in the project. We will still relate mostly in this stream to the Spring Security aspects, and we discuss about the Spring Security as a subject, and we will stick to Spring Security. So let me remind you first what this application is doing, and then I will go straight to my next subject, the subject of the today's lesson, which is of course security context. So the application that we have implemented in the past 2 lessons, you see here, actually the example was copied from the lesson number 6 to lesson 7, and then now I have copied what I have completed in lesson 7 to lesson 8, and we will use this same application to understand the things we will do today regarding the security context. And again, to remind you what we did, and then it's better to also start the application to see that now it's working, and it starts with moving the definition of the components as suggested at the beginning. So sorry for it failing at the end of the previous lesson, but yeah, sometimes it happens. It wasn't again related to anything with Spring Security we've discussed. It was only a dependency, cyclic dependency problem that I have created, related again most to Spring context and Spring fundamentals. So you see that my application started here with this change. Everything else is exactly as we've implemented in the past 2 lessons. And to remind you what we have 2 filters. One of them is taking care of the first and the second authentication step. So we are doing here a multi-factor authentication. The user first authenticates using their username and password, and then they receive an OTP, a one-time password, and then they use that OTP to obtain an access token. The access token will be then used to access any of the endpoints of the application. So that's why I have created 2 filters. One of them is for the 2 authentication steps, the other one is for all the next attempts to access any other endpoint than the login one. And then of course to implement the whole functionality we had to follow the Spring Security architecture, backbone architecture we have discussed in the previous lessons. That starts with filters, and then the filter delegates to the authentication manager. The authentication manager delegates to an authentication provider. We can implement our own authentication provider, and then if needed, the authentication provider might also use the responsibilities of a user details service and the password encoder if the authentication relates to users and passwords. If not, it's not necessary. Anyway, in the end, assuming that the authentication ends with success, then the authentication object is stored in the security context, and there's where we are now. This is on our map. The security context is the end step where the filter stores the authentication. So you can see this in our second filter that takes care of authenticating the request based on the token obtained by the first two steps the user has to do on the login endpoint. Then assuming the authentication is fine, because if the authentication wouldn't be fine, then this line, you know, it should actually throw an authentication exception. So it will basically reach line 37 I have here only in case the authentication works correctly. Then you see this is the magic line here on line 37 where we set the authentication in the security context, and from the security context the application can take it and use it for authorization. And authorization is that process followed by that follows authentication to specify which are the privileges of an authenticated individual. So after the individual has authenticated and now we know who they are, when trying to do something, then we decide if they are allowed or not to do that action. So that's authorization. And in order to be able to do the authorization, we need all the information to be stored in the security context. And this is how we get the context, and this is how we set the authentication object that will be used. And of course there's one more line here, very important. We are in a filter here, remember, so we have to delegate further in the chain when we want the request to reach at some point the end of the chain. That's the servlet, in our case the dispatcher servlet of our Spring MVC application. So important again, at the end, this is the end of the authentication. This line, this instruction here states the end of the authentication, that is storing the authentication details in the security context, and that's what we are discussing today. I want to do the steps again and reach our endpoint to see that all the implementation I have here works up to the end, and to do that I will need to access the only endpoint I have here, which is my hello endpoint. So I will do that from a postman. So first of all, the login, where I need to use a valid username and password. In my case, if you take a look in the database here, I have two users, Bill and Mary, and the passwords again are not hashed, but remember that in a real world scenario, always store them hashed. Never use passwords in plain text. Otherwise, if your database gets somehow vulnerable and is stolen, then the attacker would be able to see the passwords, and that's something that you really don't want to happen to your system. So make sure that you never store them in plain text. So we do that in our examples only for simplicity and to save time for making you aware of the other things that we discuss, but otherwise this is a really important thing that you shouldn't do in a real world application. And then what I do here, whenever I will generate, I will call the login endpoint with a proper username and password, then an OTP will be generated. And you know, this OTP basically, we imagine it's sent by an SMS or an email, because you have asked me in one of the previous lessons, okay, but how is that OTP delivered to the user, because we didn't put it in the response. So you know that when we have sent the token back, we put the token in the response of the first request. of the second request, but for the first request we didn't do that. So how does the OTP get to the customer? Where usually an OTP, an one-time password is used together with a service that proves by other means that the user really is who they state they are. In our case, by the means of sending an SMS to their phone number or by sending them an email. So by the fact that they have access to a specific phone or they have access to a specific email address, they prove a second time who they are, not only by their credentials, because that was the first step, but the second time is the way they prove who they are by the means that they have access to a specific device or an email. So that's how the OTP gets actually to the user. So I'm going to my postman and I will call this endpoint, and I'm calling this endpoint, and of course I'm getting back in the headers of the result nothing, because this is the first attempt. So this is where the OTP is sent by SMS, by an SMS message. Of course we didn't do that, but you know that I have access to the database, so I can take it from the database. And now that I have it in the database, you see it was generated for Bill, this code. Then I can take this code and I can use this code for the second authentication step. And the second authentication step is also done for the login endpoint, but here's where I have to send the OTP instead of the password. So when I send the correct OTP, then I get back in the headers of the response the access token inside the authorization header. Generally, this OTP shouldn't be available anymore. So in a real world scenario, I would have either expired it, either deleted completely from my database, and generally I would have made this OTP anyway valid only for a defined short time. But in my case, I didn't do this implementation to save time and also to allow me test easier my application. So you see I can now generate tokens as many as I want using the same OTP. And again, this is not something that you would want for a real application. Otherwise, by having one OTP, then anybody could generate tokens, and that's a really big vulnerability. So it's a really high breach in your application. So you really don't want that. So make sure that in your case, if you do more than just demo example as I'm doing here, if it's really an application, you don't keep that OTP for a long time and you can use it only once. So now we are going to the hello endpoint, and you know the hello endpoint, I can't basically use it if I don't provide a valid token. So in my case, I take the token, I put it here, and then I can call my endpoint. And this is again one important thing. Remember that the tokens generally should expire. What I have here is long-term tokens, not to say that I never remove them, which means that in my application it really is not only a vulnerability, but I have created a possible memory leak, because now adding tokens to my set, if you remember, sorry, maybe I should have reminded you first, I'm not storing them in a database. For example purposes, I have only created this token manager, and I'm storing them in a hash set, which is pretty let's say only usable on an example application. And in my case, due to the fact that I even don't delete the tokens, then this is a very good example for a memory leak. So again, this is only an example application. Be very careful what you take from it. This is only to teach you Spring Security and the Spring Security related things. So don't expect to take this application as it is from my GitHub account and use it directly. Take it, but change all the things that represent ways you shouldn't go with a real production application. So I think at least I've covered these big issues anyway. Now you've seen that it's working. I was able to do my two-step authentication, and then I was able to access my hello endpoint. What's next? Security context, of course. The purpose of today's lesson is working with the security context. And again, the security context is that place where at the end of the correct authentication, the details of the authentication are stored such that the application can apply the authorization rules based on these details. So in our case, we only have the token, and it's absolutely enough for us to prove how the security context works. We don't need more information. In a real world scenario, you will probably need here more than that. You will probably need here at least some roles or authorities, because if you want to add some rules and you want to specify that specific users can access only some specific endpoints, for example, then you will for sure need to have some roles or authorities, and we'll discuss again. I will go back to the filter chain in one of the next lessons, because we anyway have to discuss the SRF protection and course, and we didn't discuss too much, I think, on the matchers methods, so we still have to cover things on that side, and that's being related to authorization. Basically, once we finish with authentication, which is what happens with this lesson, in the next lesson we are going forward and discussing authorization, and that's where I will add more bricks to this foundation of Spring Security by making you more than aware on all the things that you need to know about authorization for the basic applications. Such that after we can go straight to the OAuth 2 implementations, and again that will be another epic we need to discuss, a very important epic nowadays, a very important subject. So stay tuned, because there will be plenty of lessons in this stream that you need to know, and that I wish anybody starting with an application with using Spring Security knows before working on that application, so that they can create the most reliable possible and the most performant possible architecture for their applications. Okay, security context. What do we need to know besides the fact that there is where we store the details for authorization, where first of all, we can access anywhere the details from the security context. So anywhere in our application and at any layer, we can access the security context. And at the endpoint layer is basically where it's the easiest, because you can actually only define the parameter of the type authentication. And you know already that authentication is the type that we use to the contract that we use to represent the authentication. We've done our own authentication implementations in this application, if you remember, and we have created for each of these authentication implementations their own filters and authentication providers. So if this is the first video that you see, I remind you that we are already at lesson number 8. So if it's something, if these are details that you don't understand, it might be because you didn't see the first the first 7 lessons. So make sure that you are aware of them, and that you see them before as well. So the simplest way when I'm at the endpoint level is just to define a parameter of type authentication. Let's see what happens if I do that. So I can simply just use the authentication, and by get name here I basically get a token, because if you remember, that's how we have created our implementation of the provider. So in the token authentication provider here, you see that we actually take the token and we store the token as the name of the authentication, name of the principal. It's just because this is our example, the simple example. So again, all this application, if you don't remember the steps, you can anytime review the way we have implemented it step by step in lessons number 6 and lessons number 7. And that being said, only by doing so I should be able to see something like hello and then the token value in my response. So that's something that I would like actually to also print in the console. You will see immediately why I do that. because once I show you this, we will discuss about what happens when the method it's executed on the different thread. So that's the next step. So that's why I will actually need also to print it in the console, because when we executed it asynchronously, then you won't get a response anyway. So for the moment, this is how I've done it. I've only defined this parameter. Automatically, my Spring application will know to inject the authentication in the parameter, and then I will print out the authentication, and here is where I will print out the token. So let's restart our application, generate a new access token, and try it to see that indeed this parameter is filled by default by my application with the authentication. So this is a really important first step about the security context. Okay, my application started, and that means I can go back. I need to generate another token because I have restarted the application. So being that I store the tokens in memory, then the tokens are no longer there. So I have to regenerate a token. I did regenerate a token using the same previously OTP, because remember here I don't delete the OTPs. That's something you should do in a real world application. But for my scenario, to make it easier, I don't delete them. So precisely for this, to make our life easier for our tests. And then I copy this token, and when I do send it, then you will see that the same token actually happens to appear in the response. And it doesn't only happens to appear, it's here because we have done this. We have actually taken the authentication from the security context, and you can see also that the application printed out the object in the console as well. So you can see my authentication with its toString implementation, the way it's printed in the console here. So we have proved by this that the Spring application knows how to take from the security context. Remember, to be able to have it injected here, we first made sure at the filter level that we have added at the end the authentication in the security context. So the reason for why the application knows what to inject here is because at the end of the authentication process in the filter, we took the authentication object and we have set it in the security context. And that's where, from the security context, my Spring application takes the object and knows to inject it into this parameter. Okay, but this way of injecting our authentication only works if we are at the endpoint level. So what happens if, for example, I am working on a separate method? For example, I'm working on a service method or a repository method. Can I obtain the authentication there as well? You might think, why do I need the authentication in another place than the endpoint? Do I need the authentication on the service layer? Do I actually need the authentication on a manager layer or on the repository layer? And the answer is yes. You will basically need to apply sometimes authorization rules at different layers of your application. So it's very true that for the moment in our stream you have only seen it at the endpoint level, but you will need to use it as we will discuss in one of our future lessons of this stream in the chapter Global Method Security. And you will see that Spring Security offers you not only the possibility to apply authorization rules at the endpoint level, but also at other layers of your application. And basically for that, you need to be able to take your authentication object from the security context anywhere. And you can do that. If you don't like, or if you simply are not able to take the authentication by parameter, you can anytime take it directly from the security context. So how do I do that? Well, actually I can anytime access the security context via the getContext static method of the security context holder, which is the same class I have used here when I have set it the authentication in the security context. So you see, this is how I take the context, and I can use this way of getting the context anywhere after the context was initialized. In our case, when I have the authentication, that's after the authentication process successfully ended. So in my case here, I can assume that I get to this method, of course, after the authentication process successfully ended. That means that I have access to my context, and then from the context you can of course get the authentication. So that's how, see, again, I take the authentication object from the context. I can put it on the second line to be easier for you to see it. And if I run again the application and retest the same scenario, you will basically see the same thing that you have seen when I have used the authentication as a parameter, because again, in case of the controller, in case of the endpoint itself, you can directly, as shown in my first example, use this as a parameter, and Spring Security will automatically know to take your authentication from the security context. This is the way. When I'm not able to do so, then I can do the way I'm showing you now, where I can refer directly to the context, and again I can do this anywhere after the initialization of the security context, which is basically after the authentication was the authentication process ended. So I have restarted my application, and let's see that indeed it works the same. Let's see that this authentication indeed contains the details about the token which I have added at the end of my authentication process. I will prove that by going back and generating a token and using that token to access my endpoint. And when I do that, I will see that the token is shown in the response as well as in the console. So you see, it basically works the same, and that's because the authentication was there and we could use it. So you see that is indeed in the response, and you can see also that I have it in the console. Good. But now let's see something else. So assuming that you did understand that we have a security context, this is the place where we put the authentication when the authentication process ends, and this is where we can take it then whenever we want to apply authorizations. You have seen that you can take the authentication from there by using it as a parameter at the controller level, and Spring automatically knows to inject it, and anywhere you can also use this security context directly expressing it from the context and taking the authentication. So you have seen all these possibilities. They work in most of the time, but not in all of the times. So when don't they actually work? When do they have a problem? Well, in this case, I'm using a normal one thread per request. I don't know, say normal, maybe the correct term would be the standard. One thread per request architecture, which means that when I do a request, automatically the application generates one thread, and that thread is taking care of the entire request. Well, we have problems in specific situations. The simplest one is probably, you can spot it when we would create a separate thread. And we would do that, for example, automatically by making this method asynchronous. And also it would happen if for some reason we create a separate thread from our method as well. So maybe not something that you would do in a web application, but Spring is not only about web applications anyway, so you might encounter this situation somewhere. So what do we do in this case? How do we solve this? This is something we'll discuss today. Something we won't discuss today is what happens for reactive applications, because we have that situation as well there. In case of the reactive applications, we don't have anymore one thread per request. We have multiple threads in a pool consuming the instructions independently, and that's another kind of architecture we'll discuss in one of our next lessons. So let's keep that for the future, for the moment, but we will discuss what happens with a different thread now. So to do that, to really prove that we will let's make this basically asynchronous. So I think that the easiest, the simplest scenario where we have more than one thread is to make our method itself asynchronous. So I can do that by simply placing the async annotation above the method. Automatically Spring will know to place my method on a separate thread. Of course, it's a little bit strange because usually I won't return something here anyway. What I return in this case won't get to the client calling it. But to make it simple, let's not change anymore the code. Let's keep it like this. It will work for our proof of concept. And this async annotation won't probably work if I don't specify that I enable asynchronous mode also in the configuration class. So basically I'll probably have to go also in the configuration class, and above the configuration class I should enable the async annotation by using the enable async here. If not, again, Spring won't know and won't interpret the async annotation. Now Spring will do that. So once I've added the asynchronous and I restart the application, let's see what happens. You will spot a very interesting change of behavior related to the security context, and that's basically what we discuss. So I have started my application and I'm going back to my Postman. I'm generating a token. It's the same flow I was doing previously for the normal approach. And I'm going here, and when I try to call it, well, I have a 200 OK and I have no response that's desired, that it is expected because it's an asynchronous method. But what's not expected and not desired is what happened here. We have a big exception, and the exception comes from the fact that the authentication is null. So how comes that the authentication printed now in the console is null now, while previously it had a value? Why is my authentication no longer there holding the token? So the only thing I've done, the only change I've done to my application was to make the method async. And why did this method basically change the way the security context work? So a question: how can you make a video how to create framework like Spring complete? How to create a framework like Spring? Wow, that's a really interesting one. Yes, I can do that. I actually can that. Of course, I can't create in a live of 1 hour an entire Spring, that's clearly, but I can show you how Spring works and how can you use reflection to create your own Spring implementation, let's say. I hope that was the question. Thank you very much for your suggestion. So I will prepare a video for you in regards to that, and you will see how a framework implements their dependency injection and the inversion of control in general by means of reflection. And yeah, that's how we'll but I will do that of course in a separate video. Thank you again for your suggestion. Cool. So now you will see, yeah, you actually see that we have a null. That was, and the null pointer exception comes from the fact that I try, of course, to call the get name method from the authentication, which is yeah, not really desired, because yeah, in this case we can see that it's is null. So let's focus a little bit on why did this become null by simply adding this async here. Well, what happens here is that when I have added the async, now Spring knows automatically that what I want is the method to be executed on a different thread. So automatically Spring will create a separate thread. Automatically the existing thread will return, so that's why I see a 200 here and nothing. And when the new thread executing the method tries to access the authentication, it doesn't get the authentication, because guess what? The context, the security context, and that's something you really need to remember, it's linked by default to the thread creating it. So I have created a security context on the thread of the request, but now I have another thread that's executing the hello method, and that other thread doesn't have the security context, doesn't have the values on the security context on the initial thread. And the reason for why this happens is because the default strategy of managing the security context implemented by this nice class called the security context holder is called mode thread local, and we have three this kind of strategies you could apply in your application. So by default is this one called mode thread local, and we could change it to a mode inheritable thread local or to a mode global. Good. Now, before going to that, let's understand what the security context holder is, and then what the mode thread local is. We have seen it in action, but we don't know yet why it's working like that. And then you will see how this relates to the fact that we have another thread now, and you will see how by changing the strategy to this second one called the inheritable thread local will solve my problem. So the security context holder, this is very easy to understand. It's normally just a class managing the security context. It's called the security context holder. Imagine it's just that object managing the security context. And it implements three main strategies to take care of the security context. The default one is mode thread local. For those of you who are not aware or don't have that much experience with threads, a thread local is an object that stores the information only and makes it available only for a specific thread. So if you have multiple threads in parallel, if thread T1, let's call it T1, stores a value on the thread local, only thread T1 will be able to see that value. The second thread T2, even if it has access to the same thread local, T2 won't be able to see that value. So thread local localizes the information on a thread. So that's exactly what happens with the security context. When the security context holder creates the security context, it's using a thread local strategy, which means it localizes the security context on that thread, which in our case, the first thread that is created is the request thread. So the thread that was automatically created because of the request done by the client. So in a standard request strategy is a request thread per request strategy, which means that a new thread is created for each request. So this way, what happens is that the information is available basically only on the thread that was created by the request, but the second thread, the one created by the framework to make my method asynchronous, that thread doesn't have the information because they can't, the second thread can't access something that is thread local on the first one, because that's how thread local works. So how can we change this? Do we have any option to change this? Well, yes, we do have options to change this, and to be able to change it, the first thing we could do in this case is to simply use the second strategy, which is called an inheritable thread local. The inheritable thread local strategy is the one that states or tells Spring, let's say it tells Spring, well, if you have a security context and you start a new thread, then copy the information from the security context of the parent thread to the child thread. So automatically Spring will do that and will copy the information from the request thread to the new thread it creates when making the method asynchronous. So let's change it. Let's change our strategy of the context holder from thread local, which is the default, to the inheritable thread local, and let's see if it works precisely as I'm telling you. So I'm going to the project config class, and one of the maybe easiest way to change this strategy is to use an initializing bin. An initializing bin is an object used called, let's say, by Spring at the moment of initializing the context. So precisely when initializing the context, we can specify a set of instructions to be executed. So let's do that. And in this set of instructions, by the way, this should be a bin in the context. In this set of instructions, we will just change the security context holder strategy by specifying the second strategy, which is this one. So you can see now I have defined an initializing bin. What I know about initializing bins is that it will be called at initialization by Spring, which is nice, which means that this line of code here changing the strategy to the second one will be called from the beginning in my application, and that means that I can assume any request happening will now be managed by my security context holder by using this new strategy. So let's see what happens if I have added this bin to the context, and now we know that we are basically changing the security context holder strategy from the default one, which is thread local, to the second one, which is called inheritable thread local. So I do restart my application, and once it's up and running again, I will recall the same method that was previously generating a null pointer exception, and let's see what's happening. So I'm calling it, and I'm generating a token, and then yeah, I use it, does the same, but going back to the console, no longer null pointer exception there. And you see the practically the authentication exists now also here. So I see a message, you can also change it by setting the value of Spring security strategy. That's true, that's perfectly true. Yes, indeed, we can use the Spring security strategy property. Also, if you go here, you will see defined the system property. Spring security strategy is also one of the ways to change the strategy, and you can use it. In this case, the reason for why you would use a system property is because sometimes you want to change this property without recompiling the code, you know. So you maybe need to change the strategy when running the application, not necessarily from the beginning. You don't know from the beginning you need to do that. Let's assume you have an application and you run it in containers, and when you spin up a specific container, in some case you want to use one strategy, and in a second case you want to use a second strategy, and that's basically when you would use a system property instead of using as I've done here from the code, changing the strategy itself. Of course, for me here it was easier to just put that initialization bin, so you know that why I've done it this way. But thank you for reminding me, because I was almost forgetting to tell you about this way. So remember that you can change the strategy also by a very simple system property. You don't necessarily need to make an initialization bin in the code the way I've done it here. Super, and you have seen that the authentication is no longer null. So we've done it. It's no longer null. How comes that now our method is async, which means it's run on a different thread, but the authentication is no longer null? Well, this happens because, and that's why again the strategy is called inheritable thread local. It means when a new thread is created, Spring knows automatically to copy the information from the security context of the first thread to the newly created thread. But you have to really be attentive with this, because it works only if Spring created the thread. If you are the one creating the thread inside your code, it won't work. Spring won't know to do that, because the thread is no longer created and managed by Spring. So be really attentive, because my example worked here for the only purpose of using async and leaving Spring the opportunity to create a thread. If I would have created my thread here, it wouldn't have worked. So let's actually test this. Let's see that if I create my thread and I will comment out my async here, and I will comment out also the enable something here. Okay, so I don't use the async functionality anymore. I just create my own. Okay, I won't use anymore here the output because I won't be able for my example to make it simpler. But what I want to do is create a runnable. So let me create a runnable here. And my runnable precisely executes this code. Okay, so it tries to take the authentication from the security context and then it prints it out in the console. And then I use an executor service. Executors. New single thread executor is enough for me. And service submit. I do submit my runnable. And then of course, usually we would shut it down on a finally, but I will spare some code here and do it like this. So we'll see what happens now if instead of leaving Spring create the thread, I create my own thread. Let's see what happens. I rerun the application. Wait for it to start. Generate a new token. So follow my same steps and then call the hello endpoint with the right token here. Okay, and I'm going back and oh cool, that's strange. I have a token which is not null. I would have expected that this is null. So that's quite strange from my point of view, because I do create my own thread. So previously this was maybe this is something new in a new version of Spring, the fact that I can actually access the authentication if I have the inheritable thread local. Well, I will try to see it. I will try to comment this out, because previously I'm pretty sure this wasn't actually working with threads created by ourselves. I will show you anyway how to deal with these situations, because I'm pretty sure it's not if it's something that's working now, it's precisely something new. It can't be something that was for a long time. So executor service like class thread. Executor service, if you didn't use executor service, is basically just a thread pool. It's creating a thread pool, and that actually means when you do a submit here, it will execute your runnable or callable. It can be here on a different thread. So that's what I'm doing here. So I execute this on a different thread. So basically I was expecting, because the thread is created by me, I was expecting that the authentication here is null. So it's a little bit strange from my point of view that I see it, that's not null, even though I have used an inheritable thread local, because it used to be that Spring didn't apply the inherit stuff for threads that were not created by yourself. But it might be a change, so it might be a change. I can't say that's not possible. Okay, now it's null. So maybe it really is a change, and Spring now it seems to know actually with inheritable thread local to do that also for the threads of your application. But that's fine. Let's assume for some reason you don't want to use the inheritable thread local. Can you do somehow else? Is there any possibility? Yes, there is, and there is a set of classes you should know, maybe not that often used. So no, I didn't see that very often used in real world scenarios, but it's worth to know about them at least. And they are the delegating security context classes. So I have actually two options here. I either can use a delegating context runnable, or I can use a delegating context executor service. So either I change the task or I change the service. So I think it won't null since you use mode. When you use that mode, it will copy the. Yes, I know that, but what happens is that this didn't work like this for the threads that you create yourself in the method. It didn't work to just put the inheritable thread local. So that's why I was a little bit surprised. Generally, and it used to be in earlier versions of Spring, that even if you are working with inheritable thread local, if the thread was created like I've done here by yourself inside the method and Spring didn't know about it, then the inheritable thread local strategy didn't work. I'm not sure if it was a bug or it was meant to be like this. The fact that's working now is cool, it's fine, we have seen that, I have commented out now and it's working as desired. Like, I see it's null again, but what I want to show you is an alternative. I want to show you an alternative to working with the inheritable thread local. And the first alternative is to use the delegating security context runnable. So instead of directly placing the runnable in the pool, you will use this delegating runnable. So what does this basically delegating security context runnable do? Is decorating your runnable. And by the way, we have a delegating security context runnable, but we also have a callable. So if you take a look on all the classes, security, sorry for that. So we have a runnable and we also have a callable. So depending on what you do, if you have a runnable, you can use a delegating runnable, which will decorate your runnable. If you have a callable and you also return, you get a value back with a future, then you can use a callable. This delegating runnable, it's basically wrapping your runnable, and when you send it now instead of your runnable, well, this basically will make it work again, even if I'm not using an inheritable thread local. So I'll rerun the application to prove that. I rerun the application, and then I have to, of course, generate one more token. Come on, here it is. And then I use the token to access the endpoint. I access the endpoint, and then I'm going back here, and you see that's no longer null. So see, even if I don't use an inheritable thread local, this nice utility class, the delegating security context runnable, allows me to specify that I want the security context to be copied from one thread to the other by the task. This is one of the options. The other one of the options is to change the implementation of the executor service itself. So you can do basically what I've done with the task, wrapping into another object that knows to copy the security context. Another option is to change the executor service. We have a delegating context executor service. Let's call it the service. And this one works pretty much the same, but instead of wrapping the task, we do that with the service itself. And then when we call the task using the service, the new service, instead of the plain one, then it will work the same. So even if you don't use an inheritable thread local, then you still have you will still see that the authentication can be taken from the security context. So I run it again, and I do the same thing. I will generate a token, and I will use it. Okay, and I will use it, and you can see that it's working again. So I'm not using an inheritable thread local, but I'm able to manage myself the threads. So I can manage myself the threads. Yeah, very, very strange. Again, I'm testing it again. I still can't believe my eyes because this again didn't work like this. I only have 5 more minutes. If you have questions, you can still ask me questions. This is the last thing I'm doing here. I really want to try it myself once more. So I will put this bin back, which changes to the mode inheritable thread local, and then I'm not using that. I will use the service itself, which creates my own thread from inside the method, and then I will rerun the application and see what happens. I'm not sure which one you believe it's a bug, but if you refer to the delegating security context and delegating runnable node, these are tools that you use to share it. So when is recommended to use Spring threads instead of manual created threads? Basically anytime you can. So I wouldn't go to creating my own threads. This is something that you will never see me doing normally, at least not in a web application. Well, basically sometimes maybe you want to have a specific kind of thread executor, but that's something that you can even customize with Spring itself. So what I would, how I would answer your question, I would say something like this. Basically, anytime you could use Spring and rely on Spring. If there's something so special that you can't rely on Spring because of that, then okay, maybe it's a I don't know, a scenario that I can't imagine now, where where a thing doesn't behave the way you expect it, then use thread created by you. But in an enterprise application, it very rarely comes that I see threads created like this, like created manually threads. And not like this, but it can be maybe that you have a schedule process, but even for scheduled, you can do that with the scheduled annotation in Spring. So yeah, generally I would say rely on Spring, and only if it's not possible, then rely on a separate thread. Combine with some configuration, thread pool, Spring will do the rest part for you. Exactly. So the answer you received in the chat is correct. It's exactly what I was trying to tell you as well. Generally we use async and we rely on the async. But now this is a theoretical lesson, so I want to show you all the aspects. I try to show you all the details. You never know what you get into. So that's why I wanted to show you also this possibility. Yeah, let me try it once more. So I won't get here, and I will put it like this. Okay, so yeah, you have it. So it's working. Okay, it's probably, maybe it was just a bug in the version I was trying. Maybe they've changed it. It doesn't really matter. I'm again not really using threads inside methods, Spring methods in production, so that's why this is a situation that yeah, maybe more theoretical than a practical one. But I wanted to show you again all the details. So the reason for why I've shown you this is not necessarily because you will find it very often in a production application, but the other way around. I expect that you maybe don't see it at all. But it's always nice to know all the alternatives. So now basically you know almost everything about the security context management you needed to. With that being said, in the next lesson we will go back to the filter chain and we'll discuss some nice filters that we need to know from the filter chain that Spring Security adds there and uses, like the CSRF protection filter and the course. We'll discuss about those, and once we finished with this filter chain as well, then we will, and the matchers method and the part that's related to the filters, then the next chapter of our stream is OAuth 2 implementations, and we will do a lot of things on the OAuth 2 implementations, starting with implementing our own systems up to using Keycloak and other specific authorization servers, identification servers like this one. We will discuss plenty of things on that chapter as well. And then we'll discuss the global method security, and then we'll discuss reactive applications with Spring Security, and then we'll discuss unit testing. So we have a lot of things to still discuss in this stream. But thank you very much for being here. Thank you very much for the messages you leave and the questions you leave in the live chat, and also for the comments, and hope to see you also for the next lesson as well. The code, as always, will be on my GitHub account after the end of the lesson. Thank you again, and have a great time, guys, and have a great time for learning.